Organic chemistry is essentially the chemistry of carbon-based. We're going to start off looking at just hydrocarbons. Hydrocarbons are any molecule that contains only hydrogen and carbon. So while these are just a subset of all of the organic molecules, they're going to be the easiest ones for us to deal with, so we're going to start with them. There are three homologous series of hydrocarbons. There are alkanes, where all of the carbon-carbon bonds are single bonds, alkenes, which contain at least one double bond between carbon atoms, and alkynes, which contain at least one triple bond between carbon atoms. And we're only going to be looking at alkenes and alkynes that contain one double or triple bond, although there are ones that contain multiple double and triple bonds. Table P of your reference table lists the organic prefixes that are going to be used based on the number of carbon atoms. So if there's one carbon atom, the prefix used is meth. 2 is eth, 3 is prop, 4 is bute, 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, and 10 is dec. So some of these are the same as the prefixes we use for just normal covalent compounds, but again, these are specifically based on the number of carbon atoms present in the molecule. So if we have one carbon atom, looking on table P, the prefix is meth. Everything, well, there are no carbon-carbon bonds, but all of the bonds are single bonds, so this is an alkane. There's not a double bond between carbon atoms or a triple bond between carbon atoms. So the ending for any alkane is ane. So we'll take the prefix based on the number of carbon atoms and put ane at the end. So this one with one carbon atom would be meth. It's an alkane, so methane. 1, 2 carbon atoms is eth, all single bonds, so ethane. 1, 2, 3 carbon atoms, all single bonds, propane. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbon bonds, all single, or 10 carbon atoms, all single bonds, decane. The same procedure is going to be used for alkenes and alkynes, except alkenes will end in ene and alkynes will end in yne. Again, the first thing we need to do is count the number of carbon atoms. Now, all of these have 1, 2, 3, 4 carbon atoms, but they are different. This has the carbon-carbon double bond on the side, on the end carbon. This one has it on the middle carbon. So because those carbons containing double bonds are in different locations, they are different molecules and therefore have to have different names. So in addition to saying this would be 1, 2, 3, 4 bute, double bond ene, we're going to state the carbon number where the double bond starts. So 1, 2, 3, 4, if we label the carbons, the double bond starts at carbon 1 and goes to the next carbon atom. So this would be 1-butene. So numbers are separated from the words by dashes. This one also has 1, 2, 3, 4 carbon atoms, so it would be butene, but the double bond is starting not on carbon 1, but on carbon 2. So this one is 2-butene. Here, again, we have 4 carbon atoms. If we count from the left, carbon 1, 2, 3, so you might think that the name of this is going to be 3-butene, but that's actually not correct, because we need to remember that these molecules are moving around in real life. So it doesn't really matter which end we start counting at. If we were behind the screen, well, then this carbon would be on the left. Or if we rotated it or flipped it. So when we're numbering the carbon atoms, we need to pick which side we start numbering at, such that the double bond starts on the smallest carbon atom. So if I were to start from the left, it would be on carbon 1, 2, 3. But I can start counting on the right as well, and this is carbon 1. So the actual name for this is 1-butene, because 1 is smaller than 3, so we're going to go with the smallest numbering that we can. Again, you would use the exact same procedure if it was a triple bond. Figure out which side to start counting from to get the smallest number. And then if it was a triple bond, you would just end it in YNE instead of ENE.